Okay, I'm going to walk you through some limits at infinity problems. I'm going to teach you the way I taught my class, and hopefully this helps you. So if we have polynomials and we're doing a limit at infinity here, the way I would teach it, I would say, okay, we're looking at top heavy versus bottom heavy. And what I mean by that is, where is the highest power? Is it in the numerator or in the denominator? Well, if we look here, we have an x to the fourth in the denominator, and we have an x to the first in the numerator. So this would be a bottom heavy function. And any bottom heavy function as x approaches infinity, we're going to get 0 as our answer. Okay, number 2. We look for the highest power in the numerator and denominator. This works with polynomials. And I can see that it's the same. Well, if it's the same, what we're going to do is we're going to divide the coefficients of those highest power terms. So the answer here would be 3/5. All right, number 3. We can see the numerator is actually bigger than the denominator. We have an x to the 6th in the numerator and an x to the 4th in the denominator. So this would be top heavy. So if the rational function's top heavy with polynomials, this is going to be D and E does not exist. Okay, number 4, we have to be careful with the terms are rearranged in the denominator, but if you see the numerator's highest power term is 7x to the 4th, the denominator is negative 14x to the 4th. So the powers are the same, so we're going to divide the coefficient. We get negative 1/2. So now this top heavy and bottom heavy really helps on problems like number 5. So number 5, and we could also use what's called the squeeze theorem for number 5. So number 5, we know that the sign fluctuates between -1 and +1. Okay? So we know my sine x over e to the x must be between these two functions here. Well, what are these at infinity? Well, they're bottom heavy functions because the numerator is a constant. So these are going to approach 0. So that means that by the squeeze theorem, what's in between there has to also approach 0. So the answer here is 0. The other way to think about it is, since sine is, again, between -1 and 1, we know that's going to stay fixed as a top function, and the bottom function is going to grow very fast, so it's going to be bottom heavy. All right, number 6. For number 6, we're going to use the fact that when we take the square root of x squared, as x is approaching negative infinity, we know that has to equal negative x. So since those are equivalent, what I'm going to do to manipulate this is I'm going to divide the top numerator by the square root of x squared. So I'm just going to keep that x squared inside the square root here. I'm going to divide the denominator by negative x. Okay, so we haven't changed its value because these two are equivalent to each other as x approaches negative infinity. Well, when we simplify this, we get 1 minus 9 over x squared in the numerator, and we get negative 2 plus 3 over x in the denominator. Well, as x approaches negative infinity, this approaches 0 and this approaches 0. So we get the square root of 1 over negative 2, so this answer would be negative 1/2. And number 7 is going to work similar to that. The only difference is now we're going to positive infinity, so the square root of x squared as we're going to positive infinity equals x. So we're going to divide the top by x squared, and we're going to divide the bottom by x. And doing the same thing we did in number 6, in this case here, we're going to get positive 1/2 as our answer.